So, good morning to all of you. Yesterday, we have discussed what is meant by a permutation, the definition of permutation. Also, we have discussed two theorems on permutations. The first is the result or a formula to use to find the permutations of an elements, and it is given by NPR is equals to n factorial divided by r n minus r factorial. Yes. So today we will see here some examples on permutations. So see, the first example is this one. How many permutations can be made from the letters of the word formula? So here the word is given formula. We have to find out the permutations of the letters which is given in the word formula under the condition for letters are used together. Then we have to find the permutation. The second one is all letters are used but first letter should be vowel. The third one is all letters are used but first two letters should be vowels. And fourth one is four letters are used but first letter should be vowel. So here in this example already we have solved first two questions. Four letters are used together and all letters are used for but first letter should be vowel. Yes. Now let us see here the solution of third one. Already we have discussed the solution of first and second statement. So here we choose first two letters should be vowels out of three vowels, because already there are only three vowels are in the word formula. Yes. So since first letter vowel can be choose in three ways, second letter vowel can be choose in two ways, and the remaining five letters can be taken from five letters. Yes. And that is 5p ways, and therefore we obtain the total permutation is equals to the first letter you can choose in three ways, that's why it is a 3 times, into the second vowel we can choose in 2 ways, that's why it is into 2, into remaining 5 letters you can choose in 5p 5 ways. Yes. And just you can calculate, we get the answer is 720 permutations where the first two letters are should be vowel in the word formula. So I think, are you understand how we can find out the permutations of the letters which are included in the word formula? Yes. Now let us see the fourth one. Here we have to choose first letter vowel taken out from three vowels. Yes, in a 3 ways. Now we have to 6 letters are left including other vowels and consonants. Yes. So we then need to choose 3 more letters taken out from these 6 letters. So it is in the how many ways? 6p 3 ways. So the total permutations is equals to the first letter vowel taken out from the 3 vowel letters in the 3 ways, and the remaining 6 letters you can take from choosing 3 more letters. Yes, out of 6 in a 6p 3 ways. So it is equals to this one. It is the definition of a permutation. You can write 6 factorial upon 6 minus 3 factorial, and you can calculate it. We get the final answer is 360. It means that there are 360 permutations to form a 4 letter permutations. Yes, under the condition first letter vowel and other remaining letters are consonants. So let us see now the example number 4. So see here the question is, how many 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5 and 6? And the condition is if repetition of digit is not allowed. It means that here the repetition of these 1 or 2 or 3 or all these digits are not allowed, but we have to form a 3-digit number which is formed by these 6 digits. Yes, means we have to find out the permutations or total permutations of 3-digit number by using the digits 1 to 6. So how we can solve this example? Yes, any idea? It is very simple, just you have to apply what? The definition of a permutation. So see here, the repetition is not allowed. We have to form 3-digit number. So we need to arrange these 3 elements out of 6 distinct digits. So the number of permutations of these 3 elements out of 6 is given by, yes, by the definition of permutation, you can write 3 is equals to 6 factorial divided by 6 minus 3 factorial. Yes, and just you can compute, we get the answer is, there are, sorry, just a minute. There are 120, yes, different 3-digit numbers can be formed by using the digits 1, 2, 3, 4, 5 and 6. Yes, so this example is very simple, just you have to apply a definition of a permutation. Under the condition, the repetitions of that digits are not allowed. Yes, so let us see here. Now the next one, this is the example number 5. How many numbers can be made between 99 to 500 from the digits 2, 3, 4, 5 and 6? So here we have to find out the total number of permutations which are made between the numbers 99 to 500 from the digits 2, 3, 4, 5 and 6. So if you observe, if you take in the first position as a 4, then what happens? Yes, is there any idea? And if you take the first digit or first position is a 5, is it possible to take the first position is 5? Is it possible to take the first position is 6? No. Why? Because these numbers are outside or in between the range of 99 to 500. Are you got my point? Yes, because these numbers are in the first place. So see here, we have to find the numbers between 99 to 500. It means that we have to find the 3-digit number between 99 to 500, and it is made from the digits 2 to 6. But if you take the choice of 3 digits 2, 3, 4 for 100th place, are you understand? In how many ways you can take that one? It is a 3p1 ways. After that, we have to arrange the remaining 2 places. What are those remaining 2 places? It is tens place and unit place. So these tens place and unit place you can take from 4 digits in 4p2 ways. Yes, and just write these in this one. In a total permutation is equals to, by multiplication rule you can write it is a 3p1 into 4p2. Why? Because both these 2 events are independent, and just you can calculate, apply that definition of permutation, and just you can take the calculation. We get the answer is 36. It means that there are 36 different numbers can be formed between the numbers 99 to 500 by using the digits 2, 3, 4, 5 and 6. Yes, so these are digits, we cannot repeat it. So let us see here now the permutation with repeated elements. So now we can take the total permutation of any objects when the repetition of that objects is allowed. So let us see how we can solve such a type of examples if the repetition is allowed. Before that, we can see here the concept of permutation. When repetition of element is allowed, it means that in the traditional way or in a regular process of a permutation where each element must be unique, yes, or distinct. So the permutation with repeated element consider scenario where some or all elements can appear in a multiple times. Are you understand? Yes, means for example, if you take the digits 1 to 6, but repetition is allowed means you can take 1 6 times, or 2 is also 6 times, 3 is also 6 times, 4 is also 6 times. If we take the permutation of this 1 to 6 digits in all, we have to include all these digits. Yes, 6 digit number if you have to form, then the permutation is repetition is allowed. Then each and every digit you can repeat it multiple times. So this is the concept of repetition of elements or sub elements, or it is also called as the objects, is allowed. So let us see one result on this one. So the number of permutations of n distinct elements taken are at a time where a repetition of elements is allowed, then it is given by, or the total number of permutation is given by n raised to r. So this is the result, or this is also the formula to find the permutations of n distinct elements taken from that r elements where the repetition is allowed. Yes. So let us see first the proof of this theorem, how we can prove this. So already it is given that the n distinct elements are there, and there are r elements we have to taken out. So the r position in the sequence can be filled independently by any of n elements. So we can proceed. The first position is, there are n choices for first position. Yes, because there are n elements. In the second position there are n choices for second position. Yes, because repetition is allowed. In the third position n choices are there, because also the repetition is allowed, and so on. What happens if you continue it, this pattern or this process for r position in the sequence? Each of that r position can be filled independently by any of that n elements. So by the multiplication rule, or we can call it as a product rule, the total number of ways to fill that r position is equals to n. N means the first position, you can choose n elements. In the second position you can choose n elements. In the third position you can choose n elements, and in the r times you can choose n elements. Yes. So this is r times n, and therefore the total number of permutations of that n distinct elements taken are at a time with a repetition of that elements is allowed, and it is equals to n raised to r. So in this way we can prove this result. Now let us see here. I think this is the next result on again the same concept. So this is the statement of that theorem. Prove that the number of permutations of n elements taken all at a time, when p of them are alike of one kind, q of them are alike of another kind, and the remaining n minus p minus q are all different, is given by. So the result is n factorial upon p factorial into q factorial. So this statement says that if there are n elements, out of that n elements, p elements are alike of one kind, means same kind of that p elements. In the same way, if you take another q elements are of alike another kind, and if you subtract that p alike elements and q of one kind element from total number of elements, then the total number of permutation is given by n factorial divided by p factorial into q factorial, and this we have to show here. So let us see the proof. We have n elements, out of which p elements are identical and q elements are also identical of one kind. Then the remaining elements is obviously n minus p minus q elements, and these elements are different or distinct. So if all these n elements were distinct, then the total number of permutations would be n factorial. Yes. So here you can take the p elements are identical, q elements are identical, and remaining n minus p minus q elements are different or distinct. So to find the total number of unique permutations, we need to divide the total number of permutations by the permutations of identical elements to avoid the overcounting. Yes. So it means that the total number of unique permutation is equals to n factorial divided by p factorial, yes, into q factorial. Yes. So this is the result. Now let us see here the remark. So from the above theorem, we can say that the number of permutations of n elements taken all at a time, where p elements are identical of one kind, q elements are identical of one kind or second kind, then r elements are identical of third kind, then the remaining elements are, just it is the generalization. So remaining elements are n minus addition of first kind elements, addition of second kind element, and addition of third kind element. It means p plus q plus r elements are all different, and it is given by n factorial divided by p factorial q into q factorial into r factorial. So this is the whole about the two theorems which are depends, or which are we can solve. We will discuss the proof of these theorems. These theorems are on the concept of permutations with repeated elements. So in the today's lecture, we have discussed the theorem, the number of permutations of n distinct elements taken r at a time, where the repetition of element is allowed, and it is given by n raised to r. Next, we have discussed the result, prove that the number of permutations of n elements taken all at a time, when p of them are alike of one kind, q of them are alike of another kind, then it is given by n factorial upon p factorial into q factorial. So we will stop here, and in the next lecture we explore the examples on this concept. Yes.